Hello everyone. Today I'm going to do the final homework, the third homework from microprocess for Dr. Ersagun Hoja in Karbuk University, and this is the homework that we will do today. As you see, guys, this is the question that we will gonna solve. We will do first of thing a hard configuration for four lids. This is the outputs, and the control is uh, port 3.2, and this is the display 7 segments. But here he just didn't write how much we need to use as a segments. But because we are going to use 16-bit to solve that question, we need like more than 7 segments. So we will use two 7 segments, not one. The operational sensor scenario, sorry, we'll make a reset first for every lid that we have. We have four lids based on the question, and then we'll make a frequency selection, security, and all the stuff. And there's here the software construction or technical requirement. We will do it all, and in the final, as he right here, we will use Protus simulator or simulation to show you how this microprocess work in the end. First of all, we go to the here the code. In this project, I designed an 8005 51 base system that toggles four LEDs as asked from the question at different frequencies using a push button and display the current mode on a multiplex 7 segment display as you see here in the code. Uh, Let me briefly walk through the architecture. First of thing, we will go to the uh, you know initialization. At the very top, we have our interrupt vectors in the initialization section. I enable external interrupt 0 to trigger on a falling edge for our button. I also configure timer 1 in a 16-bit, as I said, mode to handle our delay. I calculated the initial timer value required for the practice 62 millisecond base delay and save these values in the ROM to reload them later. And the value here I calculated, this is the value, okay. And then we will go back here to the variables, yeah, from 26 here until the CJump 42, this line. Wait, yeah. That the core state of the system is held in the R0, and it acts as our mood tracker, ranging from 0 to 4. Our main loop is entirely detected to the 7 segment display, and we always were gonna use two 7 segments, not one. And instead of using two separate ports, I use multiplexing the loop continuously and repeatedly switches between the units and 10 digits, fetching the correct numbers from the lookup tables based on the current mode in R0. And after that, we will go to what after the what after the variable which is external and ISO. So how do the frequencies change? When the button is pressed, the hardware triggers the external interrupt inside its routines. We increment the R0 mode if it's exceed 4, as you see here, inc R0 mode, the first line. Okay. Uh, we set the system back to the off state. If it is valid mode, we update the loop counter for a new frequency and exit. For the timer section, the timer this one for this timer section, the skip reset here is just an A call. It's a reload timer initial value, reload timer, reload loop counter value, and return from the interrupt. That's the job of it. I already described it in English. For the timer, the actual lid blinking is managed by timer 1 interrupt. Every 62 milliseconds, the timer overflow, we reload the timer and decrement our specific loop counter. When this counter reach 0, depending on the active mode, we use the XRL, exclusive instruction, to toggle the state of the full lid. Then we reset the loop counter for the next blank. For the table in the end, the loop timer, at the bottom of the code, I implement a subroutine to avoid code repetition when reloading the timer, along with lookup table, as you see, that store the 7 segment digits code and the required delay multiplier. Now let's move to the debug and simulate phase to see it in action. And before I do that, I will just start, the code to show you how the code does work. So here, as you see, like we're moving step by step. After we get inside the variable, which is a main loop, this one, after we get inside this one, you will see that we will not get out from it. It will be like just like an infinity loop. How we solve such a thing? We need to press the B3.2 port that we talked about in the question in the first of the video. So we will go to the port 3 here. 1, 2, 3. Sorry, 0, 1, 2, because we starting counting from 0, not from 1. We'll press that, and as you see, oh, we went over. We did the interrupt. The C jump will go to the external T0, as you see here. Yeah, we will do the increment. We increment the R0 for 1, and we started to like calling the other loops, as you see. And it will be like that for infinity loop. We could close it again, and you will see it will not make any difference because we already finished it. To see how ports will look like and how it's gonna work, we press run to show you how it will gonna work. As you see here, the port 0 and port 1, the port 0 and port 2, they are like changing fastly. But when we close the system here, it will change like slowly. Okay. Yes. And after that, after all you saw here, we will go to the Bortos to simulate the circuit, the microcircuit, to show you how it's gonna work digitally as a simulation. Uh, as you see here, we build the circuit, we take our file that we saved, and we call it, this is the circuit as you see, and we just we will gonna change, this is the digits. So of course, as a basic, I used like the question set using 7 segments, but as you see here, this is the microprocess, and we put our file, our code inside it, and here we are gonna show you how it will work after we like press these, and how it will change rapidly. And it's like, because if it's zero, it will not work easily. We will just gonna press the bottom of here that I show you, that, yeah, this one, and it will change and raised up in numbers. So first of all, we will gonna open the digital uh, screen to show you how it will work, and then we will press 1 here. As you see in the digital screen, be careful, yeah, it's become like 1. This is mean 1, as you see, because in the seventh segment, there's only 1. Now it's 2. See, it's becoming like 2 of that lines. This mean 2. When we like raise a bit more, make it like 3. Okay, so now it's still 2, as you see. We will make it 3. It will be like that. It will be more smaller, but too much. Okay. Then we make it 4. It will be more small. But as you see, because before it become the new number, it go to 1 and come back to the new number that you see. When we make it 0, it will be like the same line as you see here. And that's it. This is our circuit. This is our Proteus. We did it. Thank you for watching. And uh, as you see here, I'm showing you again how to do it. And in the end, thank you for watching. Was our homework for microprocess. And thank you.